Okay, uh, so what will we do here? We have this missing probability.
Yeah.
So what do we know about the probabilities? They have to add up to what?
To 1, right?
So
Add these up. Let's see. It would be 0.15.
okay. And temperatures follow a uniform distribution. Okay, so do you remember how we do this uniform distribution, that they go from 66 to 88? And then what's the probability that it exceeds 71? So how do we do it?
I'm not sure if I remember.
Okay, so we first draw the number line over this whole interval, 66 to 88. So let's do. Okay. So we will draw a number line over the 66 to 88. So let's say this is the number line. And we have 66 to 88. And the question was that what's the probability that the temperature exceeded 71? So he would mark the 71. And then you are looking for exceeding 71. So exceeding 71 will be which part of the number line?
From 71 to 88.
Right. So this is the exceeding 71. So what you do is you get the difference of that part, 88 minus 71.
Which is 17.
Right. And what do you think we'll divide it by? Remember, the main idea is to always divide by the total. So what do you think the total is over here?
88 minus 66.
Right. That's the total difference, 88 minus 66. 17 over 22. 0.77. 0.774. It's 0.7727. Is it?
Let me double check. Yeah, it should be 0.7727.
Okay. All right. So the mean in this probability distribution, there are two ways, and I think I've taught them both along the way. One is just by hand, and the other is through Statcrunch. So which one do you prefer?
Statcrunch.
Okay. So this one, obviously, since they don't give you the window, you have to copy the data yourself. So statcrunch.com. Stat, CRUNCH. All right, so all right. So in the first column, you will enter the X values. The probabilities always go in the second column. So the X values are 0, 1, 2, 3, 4. Okay. And then the probabilities in the second column, and they are 0.49, 0.05, 0.32, 0.07, 0.07. Okay. So then after that, do you remember the command in this kind of a group data? Stats.
Stats. Summary stats column.
Stats would be done if it was a simple data, not a grouped data. This one is a grouped data, right?
Okay.
So in a group data, if these probabilities were in integers, then you could do stats, summary stats, and this grouped binned data. But since these are not in integers, they are in decimals, the probabilities are in decimals. So if you try to do it through this way, it will just give you an error. So in this case, what we do is we do stats, calculator, and custom.
Oh, yeah.
Okay. Variable 1. And make sure that the probabilities are in the weights, which they will be because you have put them in the second column. And then this gives you the mean. And sometimes instead of saying the mean, they say the expected value. So what is that?
What is the expected value?
So if in this question I was asking you the expected value, what would be the answer?
Wouldn't it be the same as the mean?
Value is the mean. So 1.18. Oh, they also ask for standard deviations. Actually, we should have done through Statcrunch anyways, because the mean is equally easy whether you do by hand or Statcrunch, but the standard deviation is much easier by Statcrunch. So let's see. It had the standard deviation also on that window. 1.3. This one. Okay, so in this one, I told that there's a convention that whenever they put alpha in the subscript of z, so like now they put 0.08 in there. So what does that signify? What is this 0.08?
Um,
That's just
the area to the right.
yes. So what is to the right? What does the 0.08 come in? So okay, let's open the Statcrunch window. So stats. They try their best not to let you use Statcrunch in these problems, right?
Yeah.
But we know how to beat them. So stats. So what's the command?
For this one. Isn't it normal?
So stats.
Calculator normal.
Okay, and whenever it's z, the mean is 0 and standard deviation is 1. So you figured out that it's to the right. And now where does the 0.08 go?
Doesn't it go where the px is?
No, the 0.08 is the area. So the z alpha means that alpha is the area to the right. And which one is the area box?
Uh, the one across from the equal sign to the right.
So z alpha means alpha is the area to the right. Okay, so z has to be calculated. So that's 1.41. Is this the baby talking?
I'm actually supposed to be watching her, but I got my aunt to come watch her.
Okay. Is it the same baby, your sister's baby?
Yes, sir.
Okay. It's one of the best babies I've ever seen. Very quiet. Even the crying is so quiet.
Yes.
Okay. Find the area under the standard normal curve to the left of z equals 1.25. So what will we do?
Will we put it in Statcrunch?
So where does the 1.25 go?
In the area box?
So now it's saying that.
No, this one would go where the px and then the greater than or less than sign.
So 1.25. And is it to the right or to the left? Area to the left, right?
To the left.
So which one do we pick? Is this one the area to the left?
I don't think so.
Yeah, left means less than or equal to, right?
Okay. So
And actually, do you see it gives you the picture?
yes.
So the other one, if you had selected the other one, it gives you our area to the right.
And we need it to the left.
Yeah. Okay, so 0.8944. Okay, what's the probability that a randomly selected car will get through the drive-through in less than 111 seconds? So what do we do?
We'll put it in Statcrunch.
Right, so what do we put?
We'll do the 146.8 for the mean
Right.
and the 24 for the standard deviation. Oh, mine's 24. Let me see.
Okay, so
The 32 for the standard deviation.
146.8 and 32. And they said, what's the probability of being less than 111 seconds? So where does the 111 go?
After the less than sign.
Okay, so is the sign correct?
Yes.
But they said less than 111 seconds, and this one is saying less than or equal to 111. Right? Do I have a point?
Yeah.
So the reason is that in normal distribution is a continuous distribution. In a continuous distribution, it doesn't matter whether you say less than 111 or less than or equal to 111, it's the same thing. In a discrete distribution, it makes a difference. Now, can you tell me the two discrete distributions that we have mainly studied? Actually, we studied three. No, two. So two, which are the two discrete distributions that we have studied in this for this test? And the hint is that we were doing those also through Statcrunch. At least I was doing them through Statcrunch.
I don't know.
One is binomial, and now the other.
And Poisson, is that how you say it?
So binomial and the Poisson are discrete, and there it makes a difference whether you say less than 111 or less than or equal to 111. But in normal, it doesn't make any difference. So 0.1316. Okay, more than 206, nothing different. More than 206. So greater than 206. 0.0322. Okay, so what's different here in the part C?
The between. So we'll have to switch it from standard to
Okay.
between.
That's one difference. Is that the only difference?
It has been in seconds, but this is saying minutes.
Yeah, so what do we do?
We'll have to change the minutes to seconds.
Right, you have to be the same units as the mean and the standard deviation are. So what is 2 minutes and 3 minutes in seconds?
Mm, oops. 2 should be 120.
Okay, so what are you doing?
Well, I know there's 60 seconds in a minute, so just multiplying 60 and 2 and 60 and 3.
Right. And this.
And then 180 for 3.
So 0.6491. Point 91. And then more than 3 minutes. So what do we do for more than 3 minutes?
We'll switch back to standard
Okay.
and do greater than 180.
Mm-hmm. 0.1498. So is this unusual or not? 0.1498.
Um,
What's our benchmark for the unusual?
isn't it 5?
5%, right? So what does it have to be unusual? Less than
Uh,
5% or more than 5%?
Isn't it more?
No, less than 5% is unusual. So what about this?
It would be unusual because it's, well, then I'm
5%? What percentage is 0.1498?
hmm, I'm not sure.
What percentage is 0.5?
The 5 would have to be where the 4 is to be 5%, right?
Oh, let me see if you're right. That's a remarkable way to put it. Hmm. Uh, prob- so probably not. Okay, so to change into percentage, don't we just multiply by 100?
Yes.
So what do we get when we multiply this 0.1498 by 100?
Let's see. 15. If you
Right.
round.
So is it unusual?
No.
It's more than 5%. Okay, so it's not unusual because it is greater than 0.05. So actually, this should also have given you a hint of how to change into percentage because you already know it's a 5% and they say 0.05. So it means 0.05 should be the same as 5%. So you can also think that you're just moving the decimal 2 places to the right in order to convert to percentage. Okay. Find the 86th percentile. So let's see if you remember the idea of a percentile. So let's say your height among the females of your age is in the 86th percentile. What does that mean?
It means that my height is a pretty average height among people my age. It's more than 50%.
86th percentile means it's average?
I don't know. I'm just guessing.
Not tell me in numbers. If your height, if you are told that your height among the females is 86th percentile, what does it mean in numbers? Let's forget about the judgment of whether it's average or below average or above average or whatever. What does it mean in numbers concretely that you are 86th percentile in females? You don't know that you are, but let's say I'm telling you that you are. So what does that mean?
Um,
So does that mean that 86% of the girls are below you in height, or 86% of the girls are better than you, are taller than you in height? It's either one or the other. Either 86% girls are below you or 86% girls are above you.
wouldn't it be below?
Yeah, because the higher your percentile, it means the better you are doing. So if your height is 86th percentile, it means 86% of the girls are below you.
Right.
So percentile always means how much is below. So 86th percentile would mean that the area below that mark is 0.86. So the mean is 50, standard deviation is 7. Mean is 50, standard deviation is 7. And now based on what we just said, that 86% girls are below you. So where does the 86% go?
Wouldn't it go right there?
Where?
Uh, By the greater than sign.
It's the area or the probability or the percentage. Area, probability, percentage always go in which box?
The area box.
Area box.
That one.
So 0.86. And then is everything correct?
I think so.
What did we agree about? What does 86 percentile mean?
That they're less than, so we need to change that sign to less than.
So 57.56. Okay. So first, can you spot what's the difference between part A and part B?
Part B is talking about a sample of 10 second graders.
Okay, it's 12 here.
Oh.
So
yeah, and A isn't.
And A isn't. So how do we do A? A is just talking about one student.
Yeah. We would just plug it in with the mean, standard deviation, and then.
Right. So A is kind of the regular stuff that we mostly do, right?
Right.
So mean is 91, standard deviation is 10, and we are talking more than 96. 91, 10. And more than 96. Where does the 96 go?
Wouldn't it go after the greater than sign?
96.3085. Oh, I'm putting it in the wrong box. And now what do we do in part B? There's only one change we have to make in that Statcrunch window. And what is that change?
Wouldn't it be to the standard deviation?
Right. So you know that when you're talking about the sampling distribution, the mean is the same, but the standard deviation changes. So what is the new standard deviation now?
Wouldn't we just put it in as 10 divided by square root and then of the new sample, multiplied by the new sample?
I think you said it in a funny way. Have you written down the formula somewhere?
Yeah, I think I did. Well, I have it right here for
So,
this. Not the formula, just how I said it. I have it written.
okay, yeah. So in numbers, so what do we do in numbers?
Standard deviation, the
Right,
given standard deviation divided by the square root of the sample of 12.
right. So square standard deviation divided by square root of sample size. So basically we already have the standard deviation written, and then I was telling you that you could just do divided by SQRT. Is that how you do it?
Yes, sir.
Okay, good. It means you're following my videos. Mm, because I don't think anybody will teach you to do it this way. They will say, okay, you first work this out on your calculator and then put that one in here, right?
Right.
So there are certain things which I do that if I see the students doing those things, I know that they are following me. Okay. 0.0416. Okay. In a carnival game, a person wagers $2 on the roll of two dice. If the total of the two dice is 2, 3, 4, 5, or 6, never seen this problem before.
Me either.
Then the person, oh, I mean, it has the ideas that we have learned, but this set up in this particular way, I haven't seen this before. So you get two, okay, you get $4 if you get 2, 3, 4, 5, or 6 as the total. Okay, so you get, and that $4 actually means your $2 back and then the $2 additional winnings. So if the total is 8, 9, 10, 11, or 12, the person gets nothing, loses $2. Okay. If the total of the two dice is 7, the person gets 1.75 back, loses 0.25. What's the expected value of playing the game? Okay, so the probability of getting 2, 3, 4, 5, or 6. So the first question to ask is, if the dice total is 2, 3, 4, 5, or 6, then how much are you really winning? Are you winning $4 or are you winning $2?
You're just winning 2 because you're getting your 2 back.
Right, that 2 was your own. So that's just a fallacy that that's a winning part. That's not. So you're just winning 2. Okay. So we know that. So we know that basic formula of the expected value, that it's the winning amount times probability of win minus the losing amount times probability of loss. Do you ever use that? Or do you always
Um,
go to Statcrunch? So let me
I
write
I
down.
remember that. Remember writing that down.
Okay. Do you remember using it? So let's see. Expected value equals winning amount times probability of win minus the losing amount times probability of loss. Okay, so we agree that the winning amount there was $2.
Yes.
And the probability of win is basically the probability of getting 2, 3, 4, 5, or 6. So let's see if we can find that picture. Insert online pictures. So sample space of 2 dice. Sample space 2 dice. Okay, here it is. So 2, 3, 4, 5, or 6. So which are the pairs that are adding to 2, 3, 4, 5, or 6? I think they are placed they are placed adjacent to each other. So it's not hard to. So these three are 2, 3, or 4, right? And this is 3, and this is 4, and this is 4. So isn't it these 3, these, and this? No. 2, 3, 4, 5, 6. I'm stopping too short. I'm stopping at 4. So, so 1, 1, all the way up to 1, 5. They add to 2 through 6, right?
Yes.
And then we'll have 2, 1 up to 2, 4.
Yes.
And then 3, 1 up to 3, 3. Then 4, 1, and 4, 2, and 5, 1, right? These are all 2 through 6. So how many are they? 5 plus 4 plus 3 plus 2 plus 1. What is 5 plus 4 plus 3 plus 2 plus 1? Quickly. 9, 12, 15.
Yes.
Okay. Did you do it or did you just believe in me?
Well, I counted it and I got 15. So
Okay. So 2 times 15. How do I get out of this? Okay. Come on. Okay, this stupid thing should go. So 2 times 15. And then what's happening next? If it's 8, 9, 10, 11, or 12. Now, is that all? Okay, 8, 9, 10, 11, 12, the person gets nothing. So gets nothing actually means you're losing $2, right?
right.
And so, and if it's a 7, then you get 1.75 back. So you're still losing $0.25. Okay, so so we can count how many 7s are there. How many add up to 7? Isn't it this diagonal?
Yes.
Yeah, okay. So how many are there?
6.
6. So, and why am I counting 7 first? The 7 was asked as the third spot. First, it was the 8, 9, 10, 11, or 12. Can you tell me why I counted the 7 before counting the 8, 9, 10, 11, or 12?
Because your 7 is the smallest number, and then everything else will add up to.
Right, because we've already counted that the first set was 15. And then if you count that 6 of them are 7, so that's 21. And then we don't even have to count the rest because the 8, 9, 10, 11, 12 is all the leftovers, right?
Right.
And we know how many total are there. What's the total number of points in this whole thing?
Wouldn't it be 36?
It's 36
The 6
total.
times 6?
Yeah, it's 36. And so 15 of them were the 2 through 6. And then there were 6 sevens. And then how many will be the others leftovers? They all have to add to 36.
Right. If there were 6 sevens, wouldn't it be 15 of the rest?
So with those 15, I have, I lose $2. So minus 2 times 15. Oh, so that actually breaks me even right now. Because 15 of them win me $2, 15 of them lose me $2. And then what do the remaining 6 do, the ones that we're adding to 7?
They get some money back and lose some.
But what's the net result? You get 1.75 back. So are you really getting 1.2, 1.75? What's the net result of getting 1.75 back? Remember you paid 2.
Right.
So actually they're also telling you. So that means you're losing 25 cents, right? So in case of a 7, you lose 25 cents. So it would be, what will I write here? Tell me what my third term will be. So you keep doing that winning amount, losing amount stuff. It's always a winning amount times probability of win and minus losing amount times probability of loss. So it's a loss. We agree that that's a loss.
Okay.
Right? Because you're on the net, you're losing 25 cents. So I have written a negative. So what numbers do I write?
Wouldn't it be 0.25 multiplied by 6?
Right. And then I have to divide all of this by. Remember, I'm carrying the probability, so I always have to divide by the grand total. What's the grand total here? You just told me.
Isn't it 36?
Oh, I'm not calculating the probability. What was the question? Was it probability or the expected value?
What is the expected value
Okay.
playing the game once?
Right. So then you don't divide. In expected value, you don't divide. So it's just that. So what do we get?
Well, I put it in the calculator and I got negative 1.5.
So what's worrying you? If you get negative 1.5, then why are you so hesitant? Because it's
Because
not the choices?
no.
Ah. Let's see. Vegas 2. Let's see. What are we missing? Did we miss any scenario? 215. You win $2, right? If the total is this, you lose $2, right? And if the total is 7, how can that be? It's never taken me this long to spot a mistake. What's going on? Let's see. You have the same numbers in your problem?
Yes. Exact same numbers.
Person gets $4. So wager 2 and the $2 winning. Okay. 8, 9, 10, 11, 12. Oh, beautiful question. Beautiful question. Love it. Okay. So expected value was negative 1.50, right? Agreed? So
Where's that?
no. But do you agree? It was negative 1.50 according to our calculations.
Oh, yeah, negative 1.5, yeah.
Okay. So what that means is that I mean, the thing I had just discovered was that since it's a negative expected value, so you should never play this game. Right? Because what the expected value tells you what happens on average. So on average, you expect to lose $1.50 per game. So if you knew that and you were a rational person, you wouldn't play that game because you're losing $1.50 every time. And so my answer would be the expected value to play the game should be 0 because you shouldn't enter into that.
Oh, wow.
But
I
then
bet.
why have I just stopped? I was so excited when I discovered that, but what has mm, ruined my excitement just now? Oh, no. We do have to divide by 36. We do have to divide by 36. So I'll tell you why. I will tell you why. Let's see here. So what's the formula? Winning amount times probability of win, right? We wrote the formula correctly, but then when you're talking probability of win, the probability of win is not 15, it's 15 by 36, isn't it? And this one also is 15 by 36.
Okay.
And this one is 6 by 36. So it does end up being, so yeah, you don't divide overall by 36. You divide each by 36, but it ends up being the same thing. So what I was initially writing was the final result actually. So, okay, so now 1.5 divided by 36, what is it?
It'll be the 0.04.
The negative, right? So actually what this is saying is you should be willing to play this game only if somebody is willing to pay you 4 cents to play the game. Okay. So, wasn't there a problem exactly like this before? Find the z-score for which the area to the left is 0.4.
I think it was a little different, like in the wording.
Okay, okay. So tell me, what do we do here?
Wouldn't we use Statcrunch, the
Right.
normal,
Yeah.
and do the mean 0, standard deviation 1, and do, wouldn't it be less than
Right,
point?
because it was on the left, so less than. And then where does this 0.4 go?
Wouldn't it go after the less than?
Is it the area or is it the z? Let's test your English skills. Is the 0.4 the area or is the 0.4 the z?
It's the area.
It's the area. So where does it
Yeah.
go?
So it'll go in the area box to the right of the
Yeah.
equal sign.
It's so amazing how much people can do once you challenge their English skills. Okay. And usually I bring this challenge up individually when I can tell from the way of speaking of someone that their English is good. So, okay, so negative 0.25. Tell me one word which you have to know in order to do this problem. Because if you don't think of that word, you wouldn't know what to do. And the word is not present over here. It should be, it's a word that should cross your mind after reading this problem.
I'm not sure.
And I have mentioned this word in today's conversation at some point. When I was asking you a question, and then I reminded you by saying that. And then you told me something after that. I had asked you for two things. You couldn't answer the first one. I told you that, and then you told me what the second one was.
That it has to add up to equal 1? Is that what you're talking about?
That's not one word.
I don't know.
There's one magic word which you have to know to do this problem. So each time you guess a question, you either get it right or you get it wrong, right?
Right.
What is this kind of situation where there are only two options at every point? I mean, by two options, I don't mean the two possible answers. Yes, there are 5 possible answers, but the outcome of selecting the answer would be either right or wrong. So that way we have two possibilities. And that word that I have in mind, that does have in it something which indicates of two.
Binomial?
Binomial, okay. Right. So do you agree that without recognizing that this is binomial distribution, it's pretty much impossible to do it?
Yes.
Okay, so now that we've spotted that this is binomial, tell me what to do.
Okay. I know how to pull up binomial in Statcrunch,
Yeah,
but I'm
that's
not sure.
extremely important. So tell me how.
Stat
Right,
calculators, and then there's gonna be binomial at the top.
right. Okay.
But
So what
I'm
will n be in this problem? N is the number of times you repeat an experiment. So the experiment here is answering a question, isn't it?
wouldn't it be the 10 questions?
Right. So n will be 10. And little p is the probability of success every time. So what is your probability of success if you're guessing in a 5 answer multiple choice situation? There's only one correct answer out of 5, and if you're just guessing, what's your probability that you will guess the right one? Let's see how logical your mind is.
I mean, wouldn't it be just 1 out of 5?
Right, very good. I'm
Okay.
glad you didn't say 50-50 because once they asked a person that why do you play lottery, because you're giving up so much money, you're buying it year after, I mean, you keep buying the tickets and you hardly ever win. They said, well, I played because there's a 50-50 chance you either win or you don't.
Oh my goodness.
So, right, obviously, you think better than that, right? Okay. So P is 1/5. All right. So, and then the next thing is that they say to pass the quiz, you must get 60% or better. So there are 10 questions. How many do you need to answer to get 60%? I mean, to answer correctly.
Wouldn't it just be 6?
Yeah. So 6 will give you exactly 60%. But
Right.
are we asking for exactly 60%?
No, 60% or better.
Or better? So what should we do? Should we select equal to 6 or what?
Either equal to 60 or greater. So greater than or equal to 60.
Right. Not 60, but 6, right? Because X is how many questions you
Right.
get right. So 0.0064. Okay. The probability that individual has a 20/20 vision is 0.15. In a class of 38 students, what's the probability of finding 5 people with 20/20 vision? So what do you think this is?
I think this one might be binomial as well.
Very good. Because you either have 20/20 vision or you don't,
You,
right? So two possibilities. So tell me the data.
okay. Wouldn't the n be the amount of students? So 38.
Mm-hmm.
And
And little p.
that would be, what is the probability of finding 5 people with 20/20 vision?
No. That's just the probability of each person being 20/20 vision.
Okay, so it would be the 0.15.
Mm-hmm.
Okay.
38.15. Yeah, the little p is the probability of success in each trial. So 38.15. And now what are we looking for?
I'm not sure.
Well, read the last part of the problem.
But
Read the last part of the problem. Read it.
what is the probability of finding 5 people with 20/20 vision?
So what are we looking for? What should X be? In that, what you have just read, there's only one number that could be for X.
Would it be just 5?
Yeah. So would it be equal to 5, greater than, less than what? Which sign do I pick?
I'm really not sure because I personally don't see like a keyword.
So if I say that if I go to a grocery store and no, grocery is done differently here. So, I mean, do you know those countries where you actually have to ask the shopkeeper that, okay, I want this, right?
Right.
So if I ask the shopkeeper that, okay, I want 5 eggs, how many eggs will I get?
5.
So what should I pick?
The equal to?
Yeah.
Okay.
Okay, so That is 0.1786. Yeah, it'd be very sad if Math 1016 made you forget even those very basic ideas of everyday life. That
Yeah.
if I say, okay, I want 5 students to come to me, and they are just looking, say, okay, so how many do I want? Greater, do we want greater than 5 or less than 5? Right. Okay. The probability that a football game will go into overtime is 10%. In 220 randomly selected football games, what's the mean and standard deviation? Okay. So in one of the videos, I told you that, so first of all, do you recognize what this distribution is?
No.
Uh, isn't it that either the game will go into overtime or not?
Okay, so it would be binomial.
So it's binomial. And now, do you remember that video where I was telling the formulas for the mean and standard deviation of binomial?
I think so.
Let's see if you wrote them down. Yeah, the problem with that is that there's just this 1 or 2 problems that we do, and it's very rare that someone remembers that after that section is finished. So for binomial, so let's see if you can spot your notes about the mean of a binomial. Mean is equal to,
Is it n times p?
right? And then what else do we have?
Um, the standard deviation.
Okay, what is that? What's the formula for that?
Is it just the square root of the variance?
Yeah, and what is the variance?
It's n times p and then parentheses 1 minus p.
Right. Okay. Well, here, what is n and what is p?
N is, well, let me look at yours, is the 220,
Right.
and then P is the 10%.
Which is?
Um, wouldn't it just be 0.0?
Yeah. So this would be 220 times 0.1 equals 22. And then tell me what the standard deviation will be.
Let's see. I'm not sure if this is right.
No, tell me.
But I got 0.9487.
0.9487. Oh, and we don't see that as a choice. Yeah, usually when you are hesitant like this, you have a big reason for that. That's what I'm discovering. So let's see. Oh, you got no.
I think.
Yeah.
Oh no, I did do it right.
Are you sure? I'm getting 4.45. So let's see. Tell me what you are keying in.
Well, I was trying to do your numbers, and I'm not sure if I had the right ones.
Well, yeah, my numbers were 220 and 10%.
Okay. Okay, that time I got 4.4497.
Okay. This one.
So it would be 4.45.
Mm-hmm.
See if I can do mine.
Oh, yeah. Because that's scary. All right. But okay, I think you want it wouldn't be a problem costing you points here because it's multiple choice unless you somehow manage to get one of the wrong answers, which is like winning a lottery. Hmm.
Okay, I got it right.
Yeah, but the one danger of not getting one of these answers could be you may start doubting that, oh, am I doing it the correct way? You may start
Right.
doubting the formulas, and that's something which you should never do. You should always have belief that you're using the correct formula. Hmm. Okay, the length of time it takes college students to find a parking spot in library lot is normal distribution with mean 5.5 and standard deviation 1. Find the probability that a randomly selected college student will take between 4 and 6.5 minutes to find a parking lot. So what do we do?
Wouldn't this be, well,
I always get very curious when you stop like this in the middle that what is it that's, what's the bothering point?
okay. I was just making sure that it was a normal distribution, and it does say it in the
Yeah.
problem.
Yeah. Mm-hmm.
We would do stats, calculator normal,
Right.
and it gives us the mean and standard deviation. And we, instead of doing standard, we do between.
Okay. And so it's 5.5 and 1. And we have to do between 4 and 6.5. Okay, so stats, calculator, normal, 5.5 and 1, then you have to do between 4 and 6.5. 0.7745. Ah, Poisson. I wish they wouldn't tell you in Poisson problems, but usually in Poisson problems, they tell you that it's Poisson. In binomial, you have to spot yourself that it's binomial.
Right.
Okay. So tell me, what's the so you first tell me how to do the Statcrunch.
We'll go to stat, calculators, and Poisson is kind of towards the bottom.
Okay. And now the key challenge is to put the mean. Do they give us the mean?
The only number they really give us is the 1.2.
Right, but you have to read what that is. That is 1.2 per minute, right?
Right.
And remember, I made this remark that many times the average they give you is over the same period over which they ask you the question. So like in many problems, they will give you, okay, it's 1.2 per minute. And then they will ask you that how many happen in, that what's the probability that you get 4 in 1 minute. So they give you a minutely average and they ask you a minutely question. But this is one of those situations where the average is given over a different period. It's given over a minute. But what's this period over which they are asking the question? How long is this period? Between 7:26 p.m. and 7:31 p.m. How many minutes do we have between these two times?
Oh, I see. Like 5 minutes? Is that
5 minutes? Yeah. You agree? It's 5 minutes between these two times?
Yes.
Okay, so the reason why we are using this period, the 7:26 to 7:31, instead of using the 7 p.m. to 12 p.m., what's the reason why we are not using the 7 p.m. to 12 p.m., but using the 7:26 to 7:31?
In the problem, it's telling us to use the probability
Right.
between times.
The question they're asking you is over this 5-minute period over here.
Right.
Okay. So now that we know that it's 1.2 per minute, so how many will happen in 5 minutes?
Six.
What did you do?
The 1.2 times 5.
Right. So 6 is the mean.
Okay.
And now let's see if your English skills are back or not. So what does exactly 4 mean?
Equal to.
Equal to 4. Good. So what if they hadn't put this word exactly? If they had just said 4 hits, what would that mean then?
Wouldn't it still mean equal to?
Very good, very good. Now your everyday life skills are back. So, equal to 4. Okay, and so that gives you 0.1339. So fill in the blanks out on about blank of every 100 days. It's expected that there will be, okay, so tell me what goes in these blanks.
Mm. So for the first one, wouldn't you do the decimal you had times 100 to get
Right.
that in?
Mm-hmm.
So it would be 13.
Right, 13.39 rounds to 13. And okay.
And then for this one, you go back to the A and it says exactly. So you would put exactly,
Mm-hmm.
right?
Mm-hmm. And this one is fewer than 4. So what do we do with that?
All we have to do is change our sign.
Well, they're even telling you here that is not good. Right. So I mean, you should be able to spot that fewer than 4 means less than 4, right?
Right.
It's not good for the soul that they are giving you so much help. Okay, 0.1512. And then what comes here?
It would be 15 and fewer than.
And then the same thing in part C.
Yes. We'll change the sign to greater than or equal to.
Yeah, 0.8488. And so what will come here?
85.
Mm-hmm.
And then it'll be at least.
I was waiting for this one. Find the z-score that separates the bottom 70% from the top 30%. So let's see. You may have developed some idea about this one. Because this can be done in different ways, and if you know a way, I don't want to interfere with that. I just want to help you along the way.
So we would do normal in Statcrunch.
Okay. What's going on? Okay. So bottom 70% and top 30%. What do we do about that?
I'm really not sure.
So one thing is you don't have to use both of them because yes, if on the top of you there are 30%, then on the bottom of you there are 70%, right?
Right.
So you just focus on one of them. What do you like more? Do you like top 30% more, or do you like the bottom 70% more?
We can do the top 30%.
So top 30% means which way are you going on the curve? Are you going towards the right tail or going towards the left tail when you do top 30%?
Wouldn't it be going towards the right?
So then you would do the right. And where will the 30% go?
Would it go in the area box?
Very good, very good. This was your last chance today and you did it right this time. Right? Okay, so 0.3. And that's 0.5244. So if you were to do it through the bottom 70%, what would you do? What do you think?
It would be the sign, we would change it to less than or equal to and put 0.7 in the area box.
And I'll give you the same thing, 0.5244.
Okay, and there was one I didn't finish. It's number 4.
4, I think you were doing everything alongside, weren't you?
Well, it said I was wrong, so I just figured I'd come back to it.
Okay, so tell me what your numbers were.
Okay, mine's Z and then 0.04.
Okay, so what did you do?
We're already in the normal, so 2. Want to know the area to the right. Already on that.
So where did you put the 0.04?
I probably put it in the wrong spot.
Okay. Yeah, by now you know where to put it, right?
Okay, let's see. Okay, I got it right, so I probably put it in the wrong spot.
Now, another way to remember it is that, look, the subscript is alpha. And do you know that alpha is the Greek version of A?
Oh, I didn't know that.
Because the Greek alphabet starts from alpha. It's alpha, beta, gamma. We have A, B, C.
Right.
So, and A is for area. So whatever is in the subscript is actually the area.
That's a good way to remember it. Okay. Well, thank you so much for going over this with me.
Okay, that's it.
Yes, sir.
Yeah, you're helping the world as well, not just
I'm
yourself.
trying to. Well, you have a great day.
You too. So Abby, what's up?